11.8 is going to address Hero's and Brahmagupta's formulas. So for Hero's formula, the formula of the area of a triangle is equal to the square root of s times s minus a times s minus b times s minus c, where a, b, and c are the lengths of the sides of the triangle, and s is the semi-perimeter, equal to a plus b plus c all over 2. This formula was developed by the mathematician Hero of Alexandria. Brahmagupta's formula, spelled Brahmagupta, applies to the quadrilaterals that can be inscribed in circles, known as cyclic quadrilaterals. So the area of cyclic quadrilaterals, so I'll just write quad, is equal to the square root of s minus a in parentheses times s minus b in parentheses times s minus c times s minus d, where a, b, c, and d are the sides of the quadrilateral, and s is the semi-perimeter again, but this time it's a plus b plus c plus d all over 2. All right, example 1. Find the area of a triangle with the sides 3, 6, and 7. So for 3, 6, and 7, we don't have the height, so we can't use 1/2 BH, but to find the area, we'll use Hero's formula. So first of all, let's find the semi-perimeter. That would be 3 plus 6 plus 7 all over 2. So we have 16 over 2, which is 8 for your semi-perimeter. Now to find the area of the triangle, we're going to take the square root of s, which is your semi-perimeter of 8, times s minus a, so we can do 8 minus 3. It really doesn't matter who a, b, and c are. We can label this a, b, and c. So 8 minus 3 times s minus b, which is 8 minus 6, times s minus c, so 8 minus 7. So let's simplify this. We have the square root of 8 times 5 times 2 times 1, which is the square root of 8 times 5 is 40, times 2 is 80, times 1 is 80. So the square root of 80 can be simplified into the square root of 16 times 5, which gives you 4 root 5. And we have units squared. So now you have the area of that triangle that is not a right triangle. Next, find the area of an inscribed quadrilateral with sides 2, 7, 6, and 9. So here is our circle, and we can draw a quadrilateral. 2, 7, 6, and 9. So 2, 7, 6, 9. First, let's figure out our semi-perimeter. So that would be 2 plus 7 plus 6 plus 9 all over 2. 2 plus 7 is 9, plus 6 is 15, plus 9 is 24, divided by 2 is 12. So our semi-perimeter is 12, and the area of this cyclic quadrilateral would be equal to the square root of s semi-perimeter minus the first side we'll say is 2 times the semi-perimeter minus 7 times the semi-perimeter minus 6 times the semi-perimeter minus 9. All right, so then let's simplify it. We have the square root of 10 times 5 times 6 times 3 10 times 5 is 50. 50 times 6 is 300. 300 times 3 is 900. And that is a perfect square. So the square root of that is 30. And our area is 30 units squared. And that concludes your notes for 11-8.